There are a lot of ways that living and working in weightlessness impacts the human body. We've talked about them on many occasions. But this morning we're going to talk about one that you might not have thought of. Here's Lori Meggs at NASA's Payload Operations Integration Center at the Marshall Space Flight Center in Huntsville, Alabama.
We all see astronauts floating through the ISS, and it doesn't look painful, but it can cause pain. And now researchers are looking into why.
Astronauts have been developing back pain in space, and subsequently there seems to be a higher risk of a herniated disc among astronauts. Somehow NASA didn't know why during that time, so we took it as an effort in our group to find out what's causing the back pain and herniated discs from spaceflight. The idea is that in the literature, it shows that back pain is a prevalent complaint, and also some neck pain. And what's interesting is that the spines of astronauts are actually longer. They're about 2 to 3 times longer in space than on Earth. Like here on Earth, we have this variation of our height. Like in the mornings, we're tallest, isn't it? And at night, we're shortest because of the gravitation, and there's a change when you sleep. It kind of, the disc and the spine actually lengthens. But 1.5 to 3 centimeter difference per day. That's on Earth. But in space, it's about 2 to 3 times longer. We wrote a scientific paper back in 2008 when I met Dr. Hargens, when he posited the question, there is back pain in space, what could it be? We don't know. So I came to Dr. Hargens and presented my ideas. So it took us about 7 years to write the paper, believe it or not, 7 years. We gathered all the pertinent information that we can find on low back pain in space and the most likely mechanisms that's happening. So we took 7 years to write that paper, and it became known as the pathophysiology of low back pain during exposure to microgravity. It was the first viable theory ever of the most likely event that's happening with the spines of astronauts. It was published in 2008 with the Aviation, Space, and Environmental Medicine Journal. And from then on, that was 2008, NASA had decided in the same year to find out what is it really that's causing it. So we were invited to set forth a proposal. And again, what NASA wanted was quite interesting because it was the exact same principles and speculations we have. So we're now measuring the spines of the astronauts with their scans and strength and subjective scores. We are giving the astronauts a 6 battery of tests. We're giving them scans. We do MRIs to find out with spectroscopy what's happening inside the chemical components or biochemical components of the discs, because that determines the amount of water coming in or going out of the disc, as well as the amount of chemicals for degeneration. We also do the MRI again to figure out what's the size of the disc, comparing that to when they're standing up, because there is a change. And then we load them up with 10% of their body weight, and we see that there's also changes. Now, we compare that, of course, pre-flight and post-flight. The other test we're doing is a Byring-Sorensen test, which is an isometric testing of the back muscles to find out how long they can hold one position. It's in a prone position or on the stomach, but they elevate their upper torso and hold it as long as they can. We also have a dynamic test. It's called a kinematic test using a fluoroscopy, and it's a moving fluoroscopy. So it's basically an X-ray of a moving subject. We have these patient handling devices that the astronauts can use, and we measure their ability to bend forward and backward, sideways, by measuring each individual level of the spine with mathematical and computerized calculations. Lastly, we have a questionnaire, it's the Oswestry questionnaire, to find out what are they feeling. Are they feeling back pain before the examination, after the examination, and before and after testing post-flight?
So where are we in the study now? How many have we had? How many do we want?
Okay, we are approved for 12 astronauts. We were approved in 2010, and so far our study is good for 2014. But we only have 5 to 6 astronauts signed up. We have 2 completed cycles of pre-flight and post-flight of 2 astronauts. So the delay is due to the paucity of astronauts. We don't really have a whole lot of astronauts going to the space station, and we are testing them every 6 months. So there's a lot of waiting time. So we speculate that by the time we're finished with this may be around 2018 to 2019.
How do you deal with that? How does someone who, you say results aren't overnight. How do you get through that? Do you know that you're helping someone? Is that how it?
Oh yes. There's always this human need for a graffiti. Okay, and so this is the academic graffiti that I would call it an academic graffiti. Like every human being has to have this sense of purpose, a sense of mission, and somehow, in my case, helping out the space program, because it's a need for fellowship and to help mankind in the future space exploration. And the bottom line is, it has to be passion. The passion to do something that's worthwhile, that's something that's going to be used by humanity, and something that you may be remembered for life. And I think this is inherent in any human being. That's why the sense of awe for space exploration.
And since we spoke with Dr. Sayson, 12 astronauts have signed up for this study. That'll do it for us here at the Payload Operations Integration Center. Now back to you at Mission Control in Houston.